Welcome. This talk is about intent, intent MBI. I'm Chris Janz. I work for Ciena. I'm also the vice chair of the ONF's intent MBI subgroup. That's part of the NBI working group that's led by Dave Lenrow from HP. Some of these slides are his. And that in turn is part of the services area where architecture and information model work is also done. This presentation is in two parts. I'll talk for about 15 minutes, and then my colleague Raphael from HP will pick it up, and there's a little bit of theory and practice across the mix here, and let's hope the two roughly line up. So I'm going to really frame what Intent NBI is about, and I'll conclude with what we're actually doing in the ONF, how that is meant to influence and align with implementation projects. And then, as I said, Raphael will pick up and start looking at one particularly, which is the OpenDaylight NIC project. In terms of setting context, I want to start here, and those of you who have been around SDN for a while may remember this diagram from the ONF's original white paper that came out in 2012. I was part of the authorship team for that, available at this link. And that paper did a relatively good job, I thought, of kind of describing a vision for SDN, right? And we described this three horizontal layer structure that we're all familiar with, but it went a little bit further, and it hinted at, we really want something we call business applications ultimately in that application layer. And we suggested some structure and things like network services within the control layer, the idea of applications, if you like, but really associated with the control function versus the consuming applications. But in truth, the functions, what we mean by what lived in those layers, was left largely undefined. And in truth, as things got started, right, we remember the early days and we turned attention to OpenFlow, creating this means of programming a richly programmable infrastructure. And the view we took at the software at that time was a pretty primitive one, right? We wanted to let sort of organic processes start to develop that. And really, the control layer, if you want to call it that, sort of started out as really an OpenFlow mux. And really, applications sort of became whatever software people put on top of that to drive the OpenFlow engine, right? So obviously this is a long way from the sort of vision that the white paper cast. And you could argue that with things like OpenDaylight, and I'm casting some caricature and point in time here, obviously, but as efforts like OpenDaylight developed, we sort of passed through a stage you could almost call SDN as SDK, right? With sort of the beginnings of abstraction, et cetera, but really the development of piece parts through open source that we could match applications to infrastructure through the piece parts and create these engines that had function. But of course, the instantiations were still pretty well tied to, what's my utility context, to some degree, what's my infrastructure. But what Intent is about is sort of recasting, look, what were we really after in the long term here? And that's the idea of really these layers as platforms, fairly strongly decoupled, and really the control layer as the heart of a network service delivery engine, what I heard referred to this morning in the ETSI ONF joint session, as an intelligent node. So think of this as a very smart black box. We can have a whole series of application tenants sending their network service requests into this engine. The black box is figuring out how to rationalize those and how to translate really a common abstracted native language from those requesting systems into smart instantiation among the resources that are available, right? And really, Intent MBI is about creating that mode of communication between applications and that kind of black box system. It certainly forces, ultimately, the control layer to go that last full mile. And really, the spirit of this kind of communication is, we often say this, don't tell me what to do, or perhaps more accurately, don't tell me how to do it. but tell me what you want, right? And if I sort of cast from one of Dave's slides, what we're trying to get away from, and this is status quo ante, obviously, we're a long way from this already, but, between describing application needs to a network engineer and then the network engineer really composing the details of how to instantiate that on a given network, what we're trying to drive toward is that full flower of the SDN picture, where applications are directly communicating to a controller what it is they need from the collective controller and platform controller and infrastructure. And the controller is really determining and putting into effect the best network implementation based on what those requests are, what those applications need, operator policies, available network infrastructure, things going on in that infrastructure, and really no network engineer in that path. And let's look at this another way. This is really bound up in the nature of what the SDN architecture now calls planes versus layers. And what is what are the interactions between them? And the reason I say this, that we're being specific about what's going on in these systems or planes, is just because of that history, right? Obviously, if you conceive of, hey, there are applications within a control layer, and there's different types of information and action down that those things may be doing, we mean something very specific in this context. Up in the application plane, we have network service consuming systems. There are things that I have information to move between 2 points. I know why, I know when, I know how much, I know what the performance issues are, I know what flexibility I have around all of those. I need you to create that virtual adjacency or some, think NFV, some data transformation kind of function, but I need the network to give me something out of its resources. The controller subsumes everything that's involved in the determination of delivery from what is in the data plane beneath or can be created case dependent on the infrastructure beneath. So that specificity of what we mean by the systems on each side of that NBI is very important. And we go from there to thinking about intent NBI, really what is the information and sphere of action that's native to each plane given this context and interpretation, and let that define and constrain the interaction between the two planes. That's what intent is trying to do. And again, back to the title of the prior slide, in this context, the application plane, the tenant application, one of many within the application plane, is saying what it needs, and we'll talk about what that looks like, but it doesn't care how, right? And I'll hit this example at a couple of points. It's like, I need to get from here to the airport. There may be multiple service providers that can do that with different vehicles, et cetera. I really don't care how, subject to some sort of constraints that I might offer. The controller plane, on the other hand, doesn't care why. It doesn't care why you need to go from A to B. But it's all about how. It's the thing making the decisions about how to use the resources at its command, right, to deliver what it is you're asking for, potentially to try to win your business, but to meet your substantial and constraint-based needs. And also, it's the thing worrying about how efficient that delivery is from the infrastructure, right? The application, hey, if I'm taking a taxi, I might care how much it costs, but I don't really care how much money you're making, right? So from there, what does the structure look like? There's really two parts to the interaction between the two planes in the intent model. There's the actual service negotiation component, and there's an adjacency that we call mapping. And let me explain what those two things look like. The intent NBI service negotiation, that's the active, ongoing interaction for, service requests from those application tenants. It's where the, I need to get from A to B conversation happens. In some circumstances, this may be simple declaration. There may be no need for a phased negotiation. Think, here's how I want you to treat packets effectively, right? Where you're talking about potential resource contentions, impacts on adjacent services, where there are decisions to be made, there's going to be some kind of back and forth required, right? When you call for a taxi or you look for an airplane ticket, you input, I need to fly to this city and I need to be there by this time. It's going to come back with options, right? Timing options, route options, pricing options. You may go to multiple airlines. Out of that, ultimately, a negotiation may conclude with an agreement, and in some cases that may be a purchase. And the same concept is reflected here. There's the idea, furthermore, that there's some application tenant-based context and history around potentially a series of negotiations from that application tenant. And that's important to permit things like composition, right? You may, for example, submit a request that is effectively a change to an existing service. And there's a bunch of things like that you can consider. The actual service request and agreement, those would be in similar syntax. There's two components there at a high level. One is really the substance of the request, and you can think of that really as subject, predicate, potentially object, but it's the equivalent of get me from A to B. That is what I want you to do, okay? Optionally, there may be constraints, and you can call them conditions. There may be dependent constraints or conditions, but the idea here is the things that modify the substantial request. In the taxi case, for example, it would be, and I need to be at B before time C, right? In the intent model, it does not include prescriptive constraints. That doesn't mean an implementation couldn't, but in what we're trying to define, prescriptive constraints don't have a role. In the taxi analogy, that would be something like, I want you to take roadway D. In the intent model, the consuming application doesn't know there is a roadway D, right? If you tell him, well, if I take roadway D, I won't get there by time C, look, I just care about getting there at time C, right? That's not part of the negotiation. And we're trying to leave those degrees of freedom, how to fulfill, up to the delivery system. Of course, there are other aspects like, hey, the service I promised you, or that's in operation, something so drastic has happened that it's going to be interrupted. There's those possibilities. Now, the second part of this is what we call mapping. And in truth, this is where a lot of the value and a lot of the magic in the intent model happens. This is the thing that says that really the language being used by these two parties, remember that sort of native language, native information concept, their terms are intrinsically different, right? Some of the terms really are intrinsically different. If I'm a cloud system, I may know my virtual endpoints, they may be moving, right? But those are in my system. And furthermore, I may choose to deal with those at a more abstracted level. Whereas the network I'm talking to, the controller system, its relevant thing is what are my endpoints that pick up on those, right? Plus there's abstraction to be bridged, et cetera. So there's this whole problem of really a dynamic, case-specific gluing of the language between the two parties together, and that's what we call mapping. Now, once you've gone through that, and let me take a little detour, right? This is an example of a very abstracted intent request for a very simple case. Bob is allowed to access the internet, right? So you can see that the request, the substance, is actually quite simple. These are three elements of what amount to mappings, or elements of mapping. The point, of course, is that if the service request itself had been, really in the controller native speak, it might have included Bob's workstation IP address. It might have tried to figure out how the network gets his traffic to the internet and back, right? So by doing that, we would have introduced these non-portable constructs that would be subject to change, whereas the actual wish on the part of the consuming system is constant. Differences in the changing circumstances on his part, but certainly specificities of the delivery system, would change the nature of the request, the composition of the request, and that's what we're trying to avoid. And if we have all these properties, okay, we're into a world where we have portability, right? And the idea of portability is just like you make the same request for service to multiple taxi companies, multiple hotels, multiple airlines. That's what we're trying to achieve here. You only need to know what you need in terms that are native to you, based on your information, your policies, et cetera. Right? There's a lot of other characteristics that go on along with that. One of them is universality. In truth, any application request can be expressed in intent terms. You may have to think about it a little bit, but we have yet to discover a case on thinking about it where that isn't true. This idea of maximizing useful degrees of freedom in the controller plane, right? The controller plane is now free to use all the resources at its command to deliver service as best it can with the maximum monetizable features and most efficiently, right? You lose that capability when prescription starts coming in from the application requests. You lose those degrees of freedom. An important corollary to this is the idea of conflict resolution, right? If the changing composition of a particular application tenant or multiple applications are sort of coming into the same controller plane, then there's some resolution of how those are treated on the resource map that needs to be handled. The basic point here is that the more intent-like we are, the easier that problem gets, because you're as close as possible to the fundamental context and need of the request, and you've maximized the degrees of freedom in how you fulfill that from the resource base. You haven't sort of handcuffed yourself by saying, well, I don't know if this guy needs to get to the airport by 5, but he's told me I must use roadway D, therefore I can't use it for this guy, right? It's those kind of problems that get easier. And of course, the idea that you've got this natural buyer-seller paradigm, an alignment of a potential buyer-seller paradigm line. It's a service interface with that gap that the intent NBI spans. So you can think of the negotiation, it may have a price element, right? One of the things returned in the negotiation may be, I can give you what you want at this price. Okay, now very briefly, why are we doing the work we're doing in the ONF and what is it? So first of all, there's all kinds of implementation projects, and we'll hear about a couple here, that are already in progress. So why are we doing this work in the ONF? Well, it's to achieve something in particular. The architecture is feeding a core information model that we intend to be a widely used basis for a lot of architectural aspects. We've been working on a document that captures the definition and principles around the intent API. The work we're starting on now is to bring those together to produce an information model for intent. And the idea of that is to intercept the implementation projects in a useful way. Not that all implementations need to be the same, but the more there's some common basis to some fundamentals about how they operate, the better widespread use of implementations between systems on each side of that line we're going to have in the industry. So that's really what we're trying to achieve. Okay? At this point, I'm going to hand it over to Raphael to show you a little practicality.
Question. So you talked about the mapping of the names to some concrete meaning. Is that being defined, or are there?
It'll be interesting to see how that's manifest in the information model.
Is that what the information model will attempt to do?
The information model will need to deal with that aspect.
Yes. Unless you come up with some common language, it's going to be hard to create, say, portable applications or have multiple renderers do.
Absolutely. I mean, you've hit on a point which is, you get this magic portability in the negotiation because the magic is going on in the mapping process leading to mappings. And there's nothing in detail generic about those, and it's not necessarily easy to do. So I think it'll remain to be seen, how far sort of generic information model work really points at something stable happening on the mapping process side of this, or how case and implementation dependent that really needs to be honest.
So Chris already introduced me myself. So Raphael Amorim from Hewlett-Packard. I'm going to talk about the current implementation that we have for Lithium for the NIC API that is based on the work that the guys ONF are doing. I'm going to talk a little bit about the NIC API, the goals, multi-app conflict, why it happens, and how we've had the first implementation for conflict resolution. So the global actually set of goals that we have are having this high-level intent description language that you can define things without getting in touch with the details of your implementation, your network implementation, with that being independent of the physical network. We're going to talk about multi-app support. I'm going to talk in the next slides. Comprehensive visibility, know exactly in the detail the state of each one of your intents for the desired state of the network at any time. And auto conflict detection and also resolution is one of the main goals that we have. So the NIC API purpose, we have some goals. So like Chris said, it's meant to be like to specify the network, desired network behavior, and also exchange real-time network information for visibility. But some goals that we have are also make it very easy to application developers to write their code to manage the network. We all talk about during the whole conference about adoption and how we need adoption, and the easier it is to write your intents, the easier it will be to get full adoption of the community of administrators, programmers, and everybody else to write your applications. We want to support multiple applications because when you deploy those applications to your environment, there is shared, and not necessarily all the applications developers talk to each other to define what's the priority of each one of the applications, and they'll end up having conflicts in terms of the desired state. And we also want to decouple the language itself of the intent from the physical network changes, so you don't need to get attached to any detail of the implementation. So what is multi-app support and why is it needed? So that's one example of one application that we wrote here is a QoS app. So how it works, you have a voice over IP server that basically once the connection between two users making a VoIP call happens, it notifies the application running the controller telling, hey, there's a new session, in the case link here, between those two users. Then the application goes to the controller and asks, hey, where those two endpoints are located using whatever. It can be .1x authentication, IP address, anything. Detects which switches, address switches those guys are connected to. Then once they have the information, once the application has this information, basically sends slow mods doing DSCP remarking on the edges to guarantee the traffic marking. And then you have better quality. So that's one of the applications. Simple scenario of the application. Another application that you have here is a monitoring app. So basically the admin selects one user that is doing some strange activity, and he wants to get a copy of the packets of that user. Basically the same thing happens again. The application receives the comment from the admin, then goes to the SDN control, asks where is the user seated. Then you send a flow mod asking, okay, output normally the traffic of this user, but I also want a copy of the packet to be sent through the tunnel to the traffic collector. So everything happens nicely. Those two application developers developed their applications, deployed on specific application controllers, everything is nice. But once you have both apps running in the same controller, the same domain, then if you have like different priorities, then what will happen is in this case is the match fields are the same because the users are connected in the same place. So in this case, the action to forward to the tunnel will actually get prioritized over the right DSCP method there that optimizes the call. And then because of the priority, you're going to copy the traffic, but your link call will be terrible in this case. And it's very tough for the administrator to detect that. So he probably is going to detect that once users start calling him like about bad link calls or connection drops or anything. And it's very difficult to correct. And you don't want to reboot your network just to get rid of those flows. So priority doesn't solve all the problems all the time. So we're developing a intent engine inside the OpenDaylight controller that basically touches some other modules inside. So like Chris said before about the mapping services, that's the critical piece that we are developing in the Beryllium time frame that basically glue all those names together. Yesterday, actually, I had a couple people actually asking me about how we're going to do. We're going to have a design session on that tomorrow at 5:50, 5:35. And so basically when you have a request, an intent request, we extract all the information about in this case, endpoints in this example, right? So we extract the endpoint information, try to discover what does it mean, whatever the application writer is specifying, what that name means in terms of the current context of the network. We also touch network services, like Chris also mentioned, like if you have another service exposed, let's say if you want to redirect traffic, then you have to create a VXLAN tunnel, or you want to, and you need to use like a SNMP command to do that. So you don't need to know the detail, you just want a tunnel there. So the implementation will be taken care of by the intent engine that will discover the underlying mechanism, how to do that. And also topology information. So like I said, don't tell me what to do, tell me what you want. So the intent model is the final idea is having some sort of high-level language that you express, like executives may securely access the restricted SharePoint servers, but only if they have successfully completed multi-factor authentication during regular business hours. So if we explore that, if you think about the actors, the blocks there, you're going to have like subjects, like executive and multi-factor authenticate is a Boolean expression. You don't need to know the details about the algorithms involved, cryptographic algorithms, or if they're like senior executives or junior executives, it doesn't matter. So that is taken care of by the mapping service, depending on your current infrastructure that you have. You also have an action, in this case, allow. You have a condition that belongs to the whole intent, in this case, during regular business hours. So it's something that will translate. Those particular expressions are responsibility of the mapping service. That's the one that takes care of all the magic of translation to your particular domain. So talking about the specific example, yesterday I showed a demo about how do you do policy conflict resolution. So here we have two different policies. One says like infected tagged machines. So this information comes from the IDS server, but you don't need to, you as a developer that is writing a policy or intent to detect that behavior doesn't need to know which IDS server you have, how this information is getting generated. You just need to write your policy saying infected machines trying to access the server on TCP destination 8200. That is something that is not part of the intent, but I'm just detailing here. You can just say like service ports or during that for that particular context of that particular service. Employees then redirect, and another intent can be like employees trying to access the server from that particular range, log. So the idea of I'm showing the classifiers here just to make it easier to see how we solve the conflicts internally. So we treat every single policy as 3 different spaces. So you have like when policies conflict, they're gonna have those 3 particular spaces. Policies, the resolutions of just the P1 and not P2 in this case, and the intersection, that's everything that is common between policy 1 and policy 2, both intents. And the other set is everything that does not match with P2, but that matches with P2 but doesn't match with P1. So when we explore that, we know that there is a conflict that can happen there when you have, let's say, infected employee trying to access the server on port the TCP destination 91, for instance. That will cause a conflict there because you will match those two different policies, those two different intents, and then either redirect or either log will happen because it will depend on the priority of those applications. If application 1 has more priority than application 2, then one will override the other. And that's not necessarily true because you can do log and redirect because they're composable. You can do both actions at the same time. So what we do is we create different spaces for infected employee cases that basically have the non-conflict ranges separate, and the conflict range will have the composed actions. So that way, the conflict will be resolved by adding more rules, and then all the rules are completely orthogonal. They don't conflict at all. So one thing that we do is actually all the generated policies, they have exactly the same priority. So it's easier for, in the case of OpenDaylight, if we're introducing intents, so all the NIC-generated intent flows actually will be all the same priority. So it's not going to overlap other flows priorities or anything like that. So it's easy for a transition period if you have other renderers running at the same environment. So you can override NIC behavior if you want to during integration, one of your integration steps. So how do we do? Like, there's a series of decisions that you can take over time to decide if you're gonna what you're gonna do with the rules when they conflict. Then you're gonna check the actions. So if the actions are exclusive, so exclusive always wins over non-exclusive. Let's say that block is an exclusive action. So if you have block and something else, so block will win in this case. But block and monitor, for instance, it can happen. It can be composed. So you can monitor and also block. Then you're gonna check if the rules can be composed. So if you can do all the actions together in the same instruction, like we did in the redirect log action. If they can be composed, then it's okay, it's solved. So then we check for action precedence. If one action has to be executed after the other, like if you're doing service function chaining, for instance, you're sending traffic to different sets of functions, and then you want one of them actually to perform the action before the other one, you can do that. And if anything fails, everything else fails, then you always have a priority. Like you can say QoS applications are less important than security apps. So if a QoS app is doing something that cannot be leveraged, then basically that will take precedence. So the only case that you can think of that it doesn't work, but then we have to act as a referee and decide for that is if you have two QoS applications. Now one is remarking the traffic for a particular endpoint for 46, the other one is remarking to 32, then there is no way of solving the kind of conflict. The most important application wins. But the definition what is most important application is up to there's a fallback for the administrator. So in the highest level of conflict, you can arbitrate what kind of precedence takes place. But we solve all the possible conflicts till that level actually. And you have very conflicting applications. Usually that doesn't happen because they are doing the same. Usually never gonna get that situation, but it's covered as well. So that's the scope of the presentation, but I'm gonna show a little demo that I showed yesterday about, some of you guys already saw that, I'm gonna show here. So in this sample here, in this example, feature screen, let me just introduce. So what happens in this demo here is a conflict situation as well. But in this demo, when there's no conflict resolution enabled, we're gonna have those two applications trying to push two different flows. One is trying to block traffic from infected to marketing. It's one application that someone wrote. And another application that doesn't know about the other will allow traffic from finance to marketing. So what you can see is those two independent actions there, like from finance to marketing allow and infected block, are okay. But when you have something in between, like an infected finance machine, then you're gonna have, it might happen that one of them, because of priority, it can take place and be allowed to then you have a security row there. So the security hole will happen and the admin will never notice that. So in this sample case, we're gonna use those IP addresses for finance, and that's what the mapping service is doing, right? So it knows that that particular moment of time, finance is those two IP addresses, marketing will be that the 2.4 IP address, and the infected machine is the 2.1. So the demo will show what happens when we activate conflict resolution on the So we have two applications written in Python. They're basically calling the NIC REST interface. So one is the infected to marketing block, the traffic. So basically pushing intent that does that to NIC. And the other one has the finance to marketing allow the traffic. So very simple, just push the intent through REST API. Not much about it. So, hello? The GUI should. Oh yeah, the GUI ID can be provided or auto-generated, both. Yeah. So if you want control over that, because sometimes you have legacy applications that they have their own IDs, right? So you want to manage that, yeah. So if you provide it, it will be there. So we're going to check in the intent CLI. There's one feature in NIC plugin for ODL. There's no intent there right now. We're going to check it's an HP 3800 switch. Only the default flows are there right now, the go to next table flows. And I'm going to execute those two applications, the finance application and the IDS application. And then we're going to go back to the controller, check if the intents got generated. I'm going to list in the config tree, there are two intents there. Then we're going to show one of the intents. So the infected marketing block. And then we're going to show the other one. So I don't know if you guys had to play with it, but it's one of the features in Lithium. It's already available. So you can play with conflict resolution. But it's so we're going to check in the switch to see, you see that 3 rules got created, 3 new flows. And we're going to check the flow table. So in this case, the 2 flows got created. The 2 finance to marketing flows have higher priority, 2015. So the 2 machines are there. So they're both like let the flow be forward normally. And then if you notice here, the flow that has the infected machine has a lower priority. So this flow will never be executed here. So it will never be reached. So, and then you have traffic running from the infected machine to the marketing department. So if you think about it, how many applications you can have, the administrator will never check all the flows and try to, and even it's very difficult. It's like assembly language. Once you have that, it's looking at machine code, you cannot make a difference between one flow from one application and the other. Right? So it's very difficult to discover that. So we have a compilation tool that checks the conflicts. I made it offline, yeah, you see only 3 flows now, so 1 got removed, so we need to check which flow is there right now. So the previous flow, it's okay. So now 20,000 is the new priority, is the priority for all intent flows. So we don't need to use the different priorities because all the flows are orthogonal, they never match. They are uniquely matched. And then the one that got actually prioritized was the drop flow. So now the machine is completely isolated from the marketing environment. And the good part about that is the applications don't need to push the intents again. The intents is still exactly the same. There's no, so the intents in the operational tree don't change. If the behavior is expressed correctly, then it's basically immutable. You don't need to change. So it's still the finance to marketing allow and the effective to marketing block. So the network changed the behavior because of the compilation, and it didn't, the application developer didn't know what happened. So we just take care of that for you. So that's the presentation, and I'm open for questions, me and Chris. Hey. Oh, the okay, yeah. So during the compilation, when we run the compilation here, let me just get back a little bit. Yeah, exactly. So when we run the, it was very short here at the time. But if you look ahead, let me just, during the compilation, yeah, you see here, conflict detected, financed and infected, resolving conflicts. So that's what happens when we detect the conflict. So, and then they basically remove, today we remove all the flows and push the new flows. So there are lots of improvements there. We need as you guys notice, you can have much more flows than the original flows. So the operational tree will look at different. But there are lots of space for optimization of the number of flows that you can generate, and the multi-cluster aspect of it, how you take care of that, the cluster aspect, and even improvements in the design of the language that runs on top of the intent. So we provide the base building blocks for defining intents. If you think about it, it's like if you have a language, high-level language, you can create your own parser, your own parser, extract the tokens, and just pass to it, right? So you can, there's a lot of risk of fragmentation of the intent language. If you want to write your own DSL for your own domain, you can write it. If you extract the tokens correctly and you just pass to the rest unified NIC interface, then you can take advantage at the same time. Actually, that's one of the demos that Inaside with ONF actually just presented this afternoon. They have a framework for applications that you develop, controller independent intents using the NIC implementation in the case of OpenDaylight, and using a NIC mapping service on us to manage 2 different environments with the same intents. Yeah, that's actually I think there is no wrong or right in this discussion. I think it really depends on the usage, actually, the use case. I think group-based policy does a good work so you look at the data center instrumentation kind of layer. If you talk to Neutron and OpenStack in general, right? But intent, I think it's, if you think about adoption and really people start getting used, much more people than like network administrators and developers, the regular Java developers, I think intent is the way to go. I think it's easier. Group-based policy has a lot of details, but it doesn't mean that it's worse or better. It really depends on the use case. But we have a cooperation with group-based policy. We have if you go to the intent repository, there's a intent GPB renderer. So basically, we translate intents into group-based policy. You can put group-based policy in your stack, so you support multiple renderers. And also VTN, we also support VTN today. So you can push an intent and use VTN on the stack to push the flows and perform the use cases.
So this, the NIC today, does it work only with OpenFlow as the southbound protocol, or does it work with other protocols too?
Yeah, today is just like, for Lithium, we only have support for allow and block. So because it was a short time frame, but for Berlin, we're going to talk tomorrow about all the use cases that we're going to support, and of course, it's not just OpenFlow. Okay.
How about OpenStack Congress? Is there?
Yeah, there's I personally not working on that, but there's a lot of discussion about Congress and the integration with NIC. But we can talk afterwards about that. Okay.
And then we just got out of a service function training discussion. Is there potential for the intent somehow to be translated into service function?
Yes, that's one of the things that we're going to discuss during design session tomorrow. So it's a part of the roadmap. Yeah.
I'm just trying to position all these things.
Yes. So our idea is actually make it open, very easy to contribute to NIC. So we are building even like a way of writing your own actions, like a Maven archetype that you can basically describe how your action behaves, how they compose with other actions, if they're exclusive or not. And then you can write this little plugin and which action you want to perform, if you want to connect through socket to another machine and send a log message, I don't know, anything. You can express that, saying which particular name you want for that action, and that when you load that bundle, it becomes a variable for the intent language. So you can keep extending the language with more specific stuff.
So I wonder, like, there's you take enhancement overflow that allows multiple non-conflicting actions.
Uh-huh.
Do you think that may be the way to go in the future? Because multiple applications may want to use multiple things. One may want to just bring the port mailing to one traffic to a certain port, which is very benign. It's just doing one thing. The other application, like you said, is doing some
Monitoring.
rules or something, right? Some weird thing. So today, I mean, it's gonna hit only one of those rules, right? Do you think an enhancement overflow to allow multiple non-conflicting actions, not just get wrong and allow this conflicting?
Yeah, but the problem is actually in OpenFlow, it's like assembly language. You don't know about the context. You just like know the details of that particular device. You don't even know, you can have a resource constraint across the whole path, right? So it might work for the localized device, but then if you don't know the whole context, then how are you going to decide, right, what to do?
Actions, that has to be the enhancement of the protocol itself.
Yeah, but the protocol will not solve all the problems. It will solve the problems in a specific domain context, right? Hey.
Question here, so this is an application broadcasting intent for a particular pattern of traffic, this is a pattern for the service. It goes out to the controller. So the controller has to pattern service. And let's assume there are a number of devices that have to be configured so that that service can be delivered. How does OpenDaylight provision configure those devices? Is it aware of the states of all of these devices all the time so that it configures them? It only configures them if it knows it can configure them, like there's capacity of all of these devices, or does it start configuring them one by one? But when it reaches the 58th one, it realizes that it cannot deliver the service because so it has to go to a rollback. So does it do a rollback essentially, or does it always aware of the topology and the state and all the capacity and everything at every?
Yeah, that's a very good question, I think. So some kind of transaction model for configuring your devices along the path, right? So yeah, that's a question, good question. So of course you're gonna do that in terms of the current state that you have for the current representation of the topology. So if you select the path and you're configuring the devices, if one of them fail, you might fail like horribly, like this, like give up of everything that you've done. But you can try to do like another path maybe, or maybe provide it. If the intent is good enough, like Chris said actually, if you do like, hey, I want like 500 megabits a second, and then the link is exhausted, I don't have like enough bandwidth, but I can provide you like a 50 meg, it's okay. So, or I can do like, hey, I cannot guarantee the whole bandwidth, but I can increase the latency decrease the latency by maybe increasing the VLAN priority, VLAN PCP flag right in the beginning of the path. Then so that kind of resolution is pretty much open. So depending on the kind of service, like a QoS service, like I give an example here, you might have some kind of alternative way of resolving the conflict of interest. Not necessarily like conflicts in rules, but in the resource layer as well, like before going to the OpenFlow itself, or any underlying protocol, you can resolve in the service level as well. Like,
I think it's a general matter, just to add one thing. The more the intent requests have what amounts to a traffic engineering component, right? I mean, there's that character in what the requesting and constraints apply. The more you will need to be doing sort of a global view of resources and optimization problem.
Yeah.
Question. Right? Some problems can be handled through local actions. They don't worry about adjacent traffic impacts, but others absolutely do.
Well, so this really gets into the nitty-gritty because so the intent, the idea of the intent base is that so that you don't have you can abstract out, right? So you don't exactly say you don't tell the taxi drivers to take this particular path. But when you get into the taxi, you do want to say, I need to be at the airport at 5 p.m.
yeah, constrained,
You
yeah.
don't want the taxi driver to say, let me try, and then this would fail. Like
Yeah.
you look at the GPS and tell you, I think I can or cannot. So from the beginning, before attempting to go there, you want to get a response so that, because this might be a more complex system where you have an orchestrator pushing out layers of intent, and then some of them fail. So depending on the strictness of the severity of the service,
Mhm.
you don't want to.
Yeah, and that's
Yeah.
been said that not in all cases, but in cases like what you're referring to and what I just described as significantly QoS or traffic engineers requiring requests, the negotiation is necessary because the engine has to say, okay, you have to give me your set of constraints. You can't wait till you're in the taxi to tell me you need to be there at 5 at that point. But you give me your full set of, and then I look at what I can do given the actual state use of my resources, my future map for that, and I basically look at, okay, if you pull the trigger, this is how I'm going to do it. Now I know my answer, right?
Yeah. So I have just a little comment here. So in the case of the intent weird, you already like define the state machine for each intent. So you can receive notifications depending if the transitions that happen. So you get notified about, hey, I cannot fulfill the promise that you just asked here, but I have those alternatives here that are similar to whatever you want. It's like feasible enough. So we're already thinking about that and how to do that.
How about faults? I mean, so you may get into the taxi, you get into the fight, but there's an accident. You can't predict, she can't predict. So what happens then? Is there a renegotiation? Is there a notification?
So just a couple quick things on that and jump in. So this is where the separation of delivery from what I need becomes useful in those liberated degrees of freedom for the delivery system, right? Because if unforeseen things happen, that system is able to make changes, react, and its use of resources in order to attempt nonetheless to continue to fulfill the request. If that proves impossible, as I said, something has to say, you know what, I cannot get you to Denver by 5. But just like an airline, that weather comes up, et cetera, it will try to hit the schedule. We have to shuffle some things around, et cetera. But that's for the operations side. That's separated from the marketing and selling side that impacts the customer and what he wants. There can come a point of reality at which,
Yeah.
those things come to loggerheads, and there needs to be a mechanism to signal that, maybe unleash a fresh negotiation phase. But that's the idea.
And get me to the airport as fast as possible.
Is this it's very related to the question. There is a link interaction transaction, for example, a particular intent results in touching 4 devices, installing closing 4 devices. We have been successful in 3, the 4th one we failed. Are we going to roll back as
Now roll back. You can, like I said, right? You have a notification system for telling the state of your intent, if it can be fulfilled or not. It's not being fulfilled right now. So, and you can act about it.
it's partially installed? So
No, you can have like if you have a constraint saying, hey, all the traffic between Raphael and Chris allow traffic between then 7 a.m. to 8 a.m. I don't need to push something to the switches right away, right? I can wait till it's 7 or 6:55 or something like that and just push the switches.
So I think we're a bit of a couple of layers lower than.
Yeah, maybe.
You
Yeah.
have 5 devices, right? And you say, I want to add a flow to each of them. Let's just say one MAC address, one new MAC address. You can either push them in parallel because you know the capacity because you call them all the time, right? And so I'm going to write it and I know that there's capacity there, right? Or you can start one switch, second switch, third switch. Now the states of those switches have changed and the capacity is being used for potential of creating a new service. But on the fifth one, you realize I cannot provision it, and let's assume there's no alternative. In this case, you can just give up, but then now there's a leak here in the capacity, right? Because you didn't, or you have to do a rollback, right? So
Yeah.
that's what we're asking.
Yeah, but then, yeah, MDSOL supports this. Like MDSOL today supports this kind of transaction mechanism to push like flows, right? So.
But like, the thing is it responsibility of the application by the people that event, okay, I did not succeed, let me undo everything. Does it lie in the application? Rollback responsibility?
No, I think it's actually Nick can actually do that. If you try to configure the regular path, you can have like, give me all the paths. Try to configure one path. Try to do it, execute the transaction. If it fails, then I can either say to the user, hey, fail, I cannot do, or I can provide alternatives, right? I can see, hey, but I can do this other route. Or you don't even need to know about if it's one route or the other, if it's 3 hops or 2 hops, doesn't matter, right? So it really, I think it's an intent responsibility, yeah. So we can talk, it's over right now, I think, yeah. So we can talk offline. Thank you very much, all you guys. Thanks.